Hello everyone, it's me Awan and welcome back to my channel. Today we're going to be doing the 19th Cyprus Mathematical Olympiad for the 5th and 6th grade. Please like, subscribe, and ring that notification bell for more videos like these. I really appreciate all the support you guys have given me so far, and please keep it up. Let's say we can get to like 100 likes on this video, and maybe in the rest of the videos too. So please keep up the support, and I'll keep making videos for you guys. So now I guess we have to continue with the next paper. This is 2018. But yeah, so this 2018 to 19th Cyprus Mathematical Olympiad for 5th and 6th grade. Question number 1. The operation square is defined as a square b is equal to b plus 10 minus a. What is the value of the expression 7 square 5? Now if we substitute this, that means this is a and this is b. We can change that in. So basically, we're substituting, right? So we do 5 plus 10 minus 7. Now remember, when you do addition and subtraction, you don't have to do BODMAS because either way you get the same answer. So let's just go addition then subtraction first. So 5 plus 10, 15 minus 7, 8. Then if we did subtraction then addition, 5 plus 3, 8. Same thing, right? Therefore the answer is delta 8. And that's just like a simple calculation there. Yeah. In the figure below, alpha, beta, gamma, delta is a rectangle and the shaded figure is a parallelogram. What is the area of the shaded region? Okay, so to find this one, there's multiple ways you can do this. You can find the area of a parallelogram directly, or what you can do is you can find the area of the two triangles, add them together, and minus the sum of those two areas by the area of the whole rectangle. So here's the easier way. Since it says the base is 5, and you could say that the height is 6. Yeah, the height is 6. You can just do simply 5 times 6, which is 30. And then you get 30 square units. Easy, right? But now for the other one, what we have to do is that we have to find the area of this and this. Now, 8 times 6 is 48, and half of 48 is 24, so 24 square units. And here it will be the same dimension, so 24 square units again. Now we add 8 plus 5, which is 13. Do 13 times 6, 78. 24 times 2 is 48. 78 minus 48 is 30. So again, the area is 30 square units. Now, so therefore the answer is Vita. Question number 3. A rocket travels 72 kilometers in 9 seconds. How many kilometers does it travel in 1 minute and 40 seconds? So if you do 72 divided by 9, that's 8, which means 1 second, it's 1 second, that's 8 kilometers. And now 1 minute and 40 seconds is equal to 100 seconds, basically. And since we know the length that the rocket can travel in 1 second, we can just add the 2 zeros. So 8 times 100 is 800 kilometers. Therefore, the answer is gamma, 800 kilometers. And we get 800 kilometers because when we're talking about 100 seconds, we have to multiply both sides by 100, like a ratio, 1 is to 8. So if you multiply both sides by 100, 100 is equal. 100 is to 800, basically. Okay. Now, so the answer is gamma. Question number 4. Which of the following figures has the largest perimeter? Now basically, if you realize all of these are delta, but there's some squares missing. Now if you look at alpha, it's delta, and the sides are still there. This side is replaced with this side is replaced with this side, and this side is replaced with this side. So that means there's no change of perimeter. It's the same here. This side is replaced with 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 this side. So again, no change. And this side is replaced with this side is replaced with this side. So again, there's no change. But here, this side is replaced with this side, but there are two extra sides here, which means that here it has the largest perimeter gamma, and delta is just normal. So therefore, we can say the answer is gamma, the third figure. Question number 5. Hercules distributed fairly to his friends the cards from his collection of players so that each friend could get the maximum possible number of cards. He gave to each of his friends 4 cards and 5 cards were left over. What is the minimum possible of cards in Hercules' collection? Well, we can just avoid minimum here because Hercules is trying to do the maximum possible of cards. So we have to look at the biggest option here. So it's 29. 29 is the biggest option here now. Basically, we have to check that if we do 29 minus 5, which is 24, is it divisible by 4? Yes, it's divisible by 4. And this is and that means Hercules has 6 friends, and we also need the maximum number of cards, so that means maximum number of friends too. And he also has 5 cards left over. If you can check with 4x plus 5 is equal to 29, it's the same thing. So basically, therefore, the answer is eta 29. Question number 6. The following diagram shows the number of sales in thousands of 2 car models in the last years. Between which successive years did the total number of sales of the 2 models have the least change? So basically, what we're doing here is that we minus the we add the negative with the positive. The negative value, if here, they're both going down, which means it's negative, and that means it's the smallest. You can even check with the numbers. Minus 19, minus 20. That's minus 39 altogether. So that's the smallest, definitely. Meanwhile, in the second one, we have 141 and 99. Which is 42, and then we have minus 20, so 22. That's small, but it's better than the other one. And then we have 2014 to 2015. The negative here is really big, minus 63. And then we only have a plus 28, so minus 63 plus 28. Oh, yeah, so basically 63 minus 28, you could say, is 35. So we got minus 35 for this. For 2015 to 2016, we have a jump of 42. And we have a small, and then 128 minus 107, that's only 21. So 42 minus 21, it's 21. And now 159 minus 120 is 39. 148 minus 107 is 41. 41 plus 39 is 80. Now basically, we're not looking at what is the biggest, what is the smallest, the least change, which means it's not that big of a negative and it's not that big of a positive, but it's just in between. It's okay. Here 2015 to 2016, And it says that because after 22 there's 21, and then it goes directly into small negative into smaller negative numbers, which means that you could say 2015 to 2016 delta is the answer. The following rectangular mirror broke. Which of the following is a missing piece of the mirror? It's easy. You can basically just imagine that by just drawing the missing corner again. And alpha is wrong because there is no pentagonal shape. There's no corner like that. Again, the bigger part of this shape is wrong again. There is no like horizontal slanted whatever that's supposed to be. It looks like the piece, but you can't exactly fit it in. This is the wrong pentagon again, but this you can fit it in, which means that delta is the answer. Pretty easy, right? Now, question number 8. What is the units digits following product? Now we're multiplying all the odd numbers together. So when we do this, we have 1 times 3 times 5, 15. So once we end in 5, like every odd multiple of 5 ends in 5. Odd multiple of 5 ends in 5. So basically after 15 you got like odd numbers, so that means that it'll have to be an odd number every single time, which means it won't diverge into anything else but 5. The unit digit won't diverge into anything else but 5, so the answer would be gamma 5. What percentage of the shape is the shaded area? Okay, so you count there 1, 2, 3, 4 squares here, 1, 2, 3, 4, 5 squares here. 4 by 5 is 20 squares in total. And now you have to count how many shade squares there are. There are 3 pairs of these squares, so 6 in total. And then we have 9. So 2, 4, 6, 9, and then 12. So basically 12 upon 20 is shaded. And since we know and then it's asking the percentages of the shaded shape, the shaded part, which means since we know percentages are upon 100, you can multiply both sides by 5. So multiply by 5, you get 60 upon 100, which is equal to 60%. Okay, so basically the answer is 60% eta. Pretty easy. And if you want to check, you can just go back to 60 upon 100, divide by 5, and divide by 5, and then just count the 12s. Count the 12 and the 20. Now, question number 10. Antonis, Fanny, and Panos cut up pizza into 3 equal pieces, and each of them took 1 piece. Fanny ate 1/6 of the total pizza. What part of her own piece did she eat? Okay, so let's just imagine this pizza. So it's divided into 3 pieces. Let's say this is Fanny's piece. She ate 1/6 of the total pizza. A half of a third is 1/6, which means she ate this much. What part of her own piece did she eat? That's basically a half of her own piece, since we already know that a third times a half is 1/6. But here it has to be written in equations, and since we don't see any a third times a half, we have to find the opposite way by using like fact families. Basically, fact families are like how you can write equations different ways. You can say 1/3 minus a half is equal 1/3 times a half is equal to 1/6. A half times a third is equal to 1/6. 1/6 divided by 1/3 is a half, and 1/6 divided by a half is 1/3. Now let's just look if we can find any of these here. That's vita. We can find this here, which means that the answer is vita. And it's an obvious thing to do, because once you have your piece of 1/3 and then you have the 1/6, and then you have 1/6 of the total pizza. You divide them together to get how much is the 1/6 of the 1/3 basically. So yeah, therefore the answer is beta. Joanna used a reduction tool of a photocopier to get a document to 40% of its original size. What percentage of the enlargement tool should be used to create another copy, which is the size of the original document? Okay, so we wouldn't say 60% because that actually is not how it works. Now let's say we have 40% of 160, that's 64, so we have 96, that's 60% left. Now, if we said that, now when we look at 96, what can we do? Well, we can do like, we can't do 96 times something is equal to 160, so that means that it's not a whole number. However, if you do 96 times 2, but that's 192, but that's already too big. However, 96 then divided by 2, 48. 192 plus 48 This is where it gets a bit confusing. We get 140. What? We got 230. Well, the answer is 250%. But maybe, just maybe, oh, wait, so it says it's 40% of its original size. Sorry, it says it's 40% of its original size, which means you minus by 60 though. So once it's 96 is 64. Now basically we have to find how we get back to 250 from here. So let's do 128 and half of 64 is 32. So 128 plus 32 is 160. So we go back to the whole and the answer is 250%. Basically, what it actually said is that since a document is 40% of its original size, which means it's 40% now, that it was reduced by 60%, which means once we get that 64, if we do 250%, which is basically 64 times 2 and then plus the half of 64, you get 160. Therefore, the answer is eta. Which shape in the sequence will consist of 36 dots? So let's say we have 1, we have 3, we have 5, and we have 9. Wait, oh sorry, 6, and then we have 10. The difference is always increasing by 1, so that's plus 2, plus 3, plus 4. So before we do that, we have to check the possible values for an equation, because it's not like the next one. We have to find an equation to find out which one's 36 dots. Then we substitute the 36 as the answer to that equation, the sum, and then we can find the number. So okay, and remember x is the position of the pattern. So okay, first it can be 2x minus 1, it can be 3x minus 2, it can be 4x minus 3. Let's start with these three first. So if we have the second now, 4 minus 1 is 3, that works, but 2 times 3 is 6 minus 1, 5. It's 6, sorry, so that's wrong. So for the second one, 3 times 2, 6 minus 2, 4. That doesn't work either. But now we have 4x minus 3. 4 times 2, 8. Wait. 4 times 2, 8, minus 3, 5. That doesn't work either. Which means that there must be a simple thing that's happening here. Something that we're missing. Let's say that we started with 0. 3x plus 2. 3x plus 1. No, sorry. 2x plus 1. Now when we substitute 0 for the first part, 2 times 0 is 0 plus 1, 1. Then for the second one, 2 times 1, 1 2 times 1, 2 plus 1, 3. 2 times 3, 6 plus 1, 7. So that makes it a bit more complicated still. So, Now we can go with 5x minus 4 maybe. 5 minus 4 is 1. 5 times 2, 10 minus 4 is 6. That's where we realized that we're going out of way. So if we can't find the formula like me, so now we can just do plus 5 plus 6, and then we can just follow this until we get 36 here. And that's 5th, 6th, 7th, 8th. So therefore the answer is gamma, the 8th one. If you know the formula, you can message it down in the comment below, but here's the answer. If you can't find the formula, it's the gamma, the 8th. And you can just do it directly by just adding the rest of the differences, or the spaces between them. Now, question number 13. On a numerical line, the interval from a third to a half will be divided into 6 equal parts. The corresponding number will be placed at the end of each section. Which number will be after a third? If we look at 36, it's a promising number really, because 36 is divisible by 6, and also it's repeated 2 times. So let's take the common multiple as 36. So 1/3 will become 12 upon 36, and a half will become 18 upon 36. It works well. We have 13 upon 36, 14 upon 36, 15 upon 36, 16 upon 36, 17 upon 36. So that's 1, 2, 3, 4, 5, 6 spaces. So basically it's 6 spaces in total, and there are 6 sections. So which number will be after a third? A third in this case is 12 upon 36, so after that 13 upon 36, therefore the answer is alpha. Question number 14. Today is Sunday. What day will it be in 220 days from today? Okay, so what we can do is we basically do 220 divided by 7. Let me put the 2 here, 3, 21, 1, 1. and then remainder free. So basically, after 31 weeks, it'll still be Wednesday, but there's a remaining of 3 days left. I mean, sorry, after 31 weeks, it'll still be Sunday, because after 1 week, the day that you're on right now will be the same as the day after 1 week. So after 31 weeks, it'll still be Sunday, obviously, but there's 3 days left. So after Sunday, there's Monday, Tuesday, Wednesday. So once you get to Wednesday, you know the answer is gamma. Easy, right? Now, question number 15. Nick wrote 7 consecutive integer numbers. If the sum of the three largest numbers is 30, what is the sum of the 3 smallest ones? Okay, so basically there's x. So it's 7 numbers, right? So x plus 1, x plus 2, x plus 3, x plus 4, x plus 5, and x plus 6. So these 3 are equal to 30. So when we add them together, we get 3x plus 15. Since 4 plus 5 is 9, plus 6 is 15, and x times 3 is 3x. So 3x plus 15 is 30. We minus both sides by 15. 3x is 15. Divide both sides by 3. X is 5. Which means this is 5, and it's asking the sum of the 3 smaller ones, so these 3. So 5 plus 6 plus 7. 5 plus 6 is 11 plus 7, 18, which means basically the answer is 18. It's gamma. Okay. Now, the ratio of John's money to Peter's money was 4:7. After John spent half of his money and Peter spent 60 euros, Peter had twice the money of John. How much money did John have at the beginning? Okay, so basically, it's 4:7, and John spent half of his money. So this is John, this is Peter. So he divided by 2 here, and Peter spent 60 euros. But the reason why I put a 4, but you could ask me, why did you put a 4? How do you know? It's because it says Peter has twice the money of John. So John has 2, so that means 2 times 2, 4. Peter has twice the money of John, it's 4. So basically it's minus 60. 7 minus 4 is 3. So this minus 3 is equal to minus 60. 3 is 60. So 1 is 20. So we know the base value here is 20 in both ratios. So how much money did John have at the beginning? So you can just do 20 times 4 and you get alpha 80 euro. You can check this later, like basically, let's say, so basically John would have before John had 80 euro and Peter had 140 euro. 140 minus 60, like 4 times 140 minus 60 is 80, and 4 times 20 is 80 also, so that works. And half of the 80 is 40. Now when you have 40 is to 80, obviously that's a half, since 40 times 2 is 80, which means it still works, and the answer is alpha. Let me write down the check method here. So oopsie daisies. 7 times 20 is 140. 80 divided by 2, that's 40. It's still there, you see? Then minus 60, it's 80. 40 times 2 is 80. And also, 4 times 20 is 80. So that works. So again, the answer is alpha 80 euro. What is the smallest possible sum of dates of Mondays in November? E.g. the 1st of November, 2nd of November, 3rd of November, 4th of November. Give a total of the sum of dates 10. Basically like 1 plus 2 plus 3 plus 4 is the example what they're giving here. Well, if we don't know what the first Monday is, we can just start with 1, because normally if you don't know what it is, just start with 1. So here we have the 1st of November, and then we add we add a 7, because that's the number of days in a week, and then it'll still be a Monday after that, as we said in question number 14. So basically 1 plus 8. Now 8 plus 7 is 15. 15 plus 7 is 22. 22 plus 7 is 29. And since we know that there are a total of 30 days in November, we can stop there. So basically 29 plus 22, 15, 8, 1. 9 plus 2, 11 plus 5, 16 plus 8 is 24 plus 1 is 5. Then you put the 2 here. 2 plus 2, 4 plus 1, 5 plus 2, 7. So therefore the answer is delta 75. Easy, right? Now let's go with the next one. How many of the following triangles have the same area? So first we have alpha, beta, eta. So you can draw that one like this. It's a normal right angle triangle. But let's see if we can get any more like that. Though there's only going to be like one equal one. Oh wait, 1 minute. There we are. I'll just draw it like that. Delta, gamma, zeta. So now we have delta, gamma, zeta. They're not equal, so we can start from delta, gamma, zeta now. Theta, alpha, gamma. So we have here, and then we add it with the gamma, which is here. And you see that the blue and the yellow triangles are the same. So you know that they're equal. They have the same area. Sorry for the not as accurate area drawing, but this is with a start lessons online, so sometimes some mistakes can be made. So now gamma, beta, eta. So this is gamma, this is beta, and we have eta here. It's the same as the others, so we can do this. Now we have zeta, eta, theta. Zeta, eta, theta. It's the same again. It works. Now eta, delta, beta. So we have eta and delta, and then we have beta here. It's the same as the others again. So we have this alpha, beta, theta. Wow, this is getting crazy now. If you notice, wait, let me just do this. If you notice, it's just like this, which is too thin, which means that we know that's wrong. But eta, delta, I forgot the name of that letter. Yeah. Okay. Yeah, so basically that triangle, it's this with this, and then you have this here. So basically that's the same. So 1, 2, 3, 4, 5, 6. So the answer is gamma 6. There's 6 equal areas, but basically you should draw them one by one, and people who just look at them directly wouldn't exactly understand, but you understand if you draw them step by step. So yes, it's gamma. Question number 19. Saki says 24 equal small cubes. He will use them all in order to construct a rectangular parallelepiped. How many rectangular parallelepipeds of different dimensions can he construct? Basically, we have to make some. We have to make the biggest possible answer. In this case, really, because it can be anyway. So let's just go with 6 to see what we can do with that. So if we have 6, we can do 36 divided by 6, which is 6. So like 24 equal small cubes, their areas are all 36. Let's just say that 36 divided by 6 is 6. So now we have to make parallelepipeds of different dimensions, and here they're all listed down. The great thing is that 1 exists. And basically with 1 you can make so many different dimensions. Like, I know we're using the same numbers, but however the dimensions are different. Like here, this is the length, breadth, And the height, we can just say that randomly. So the length is 1, breadth is 2, and height is 3. Here the length is 1 again, but the breadth is 3 and the height is 2. It can be mixed up in any way you exactly want, but we have 1, 2, 3, 4, 5, 6 possibilities here. And anyways, like remember factorials, when the amount of really lengths here, dimensions here is 3. And 3 factorial is 6, since 1 times 2 times 3 is 6, which means there's 6 ways for this to go, and there's 6 ways for this to be, for this parallelepipeds to be constructed, and therefore the answer is eta. Easy, right? Now question number 20, which is actually more easier than you think. Costas wants to cover a rectangular table of dimensions 120 to 120 centimeters to times 216 centimeters square tiles. What is the smallest number of tiles that can be used in order to cover the table exactly if you're not allowed to chop tiles? Now to find how many tiles we need, we basically have to find the area of a tile divided by the area of the whole floor you're putting the tiles on. We already know 120 by 216, but we don't know the dimensions of the square tiles. So that's why we wrote x times x. It's a square number. So basically, if it's saying you're not allowed to chop tiles, we need a factor which divides by 120 and 216. You realize that 120 divided by 4 is 30, and 216 is also divisible by 4. It's the same with 6 too. 4 times 6 is 24. That actually works as well, since 24 times 5 is 120, and 24 times 9 is 216. So that works perfectly for you, and it looks like it's the highest denominator you can make, highest multiple you can make. So we can substitute the 24 times 24 here. Now basically we can just simplify. So you can do cancel. You get 5 here. Cancel. 9. 5 times 9 is 45. Your answer is right there. Eta 45. Oh, sorry, but we actually had to write it like this. That's how it works. So you have 5, 9, 45, and again. So therefore the answer is eta 45. You just need 45 tiles. It's all you needed to do is that you had to find a factor, and then you had to simplify the formula, the equation you had, by basically cancelling it out. We're doing 120 divided by the factor and 216 divided by that factor to get 5 times 9, which is 45, and that factor is 24. So, and we had to get the biggest one because otherwise there would be a longer simplification and it wouldn't work as well. So, question number 21. Costas built a large solid cube using 27 small equal-sized cubes. Then he painted the outer faces of the big cube in blue. How many of the small cubes have only 2 painted faces? Oh wait, sorry. Before we go on to question number 21, another reason why we had to get the biggest factor is because it says the smallest number of tiles we need. So when you want the smallest number of tiles, you have to get bigger dimensions. So anyways, yes, question number 1. So Costas built a large solid cube using 27 small equal-sized cubes. Then he painted the outer faces of the big cube in blue. How many of the small cubes have only 2 painted faces? So this basically depends on the dimensions. Here the dimensions are 3 by 3. So when you draw, so that it's pretty easy to draw, visualize without a formula. But if there are bigger ones. You have to use formulas instead of imagining. So look, so basically when we're visualizing it, 2 painted faces is the edges. So we have 1, 2, 3, 1, 2, 3. Wait, sorry. Yeah, so 1, 2, 3. 4, 5, 6. Wait, but then there's a problem. There's a big problem then. Sometimes you can get confused because like these 4, 5, and 6, like 4 and 6 are actually colored by free sides. Same with 1 and 3. So when you're actually doing it, this would be 1, 2. Then there would be 3 and 4. So they are basically the ones at the middle. Then there would be 5 here, 6 here, 7 here, and 8 here.